Hello and welcome to the introduction of Hyperlayer, a tool that will help you debug your Ruby apps 10 times faster. So what is Hyperlayer? Hyperlayer is an entirely new way to visualize your Ruby apps that combines the application flow with the state and the code itself. If you think about how those three elements live and how they work together at the moment, you've got your code itself, which lives in your code editor. It is structured however your organizational preference is. For us, for most Rails devs, that's MVC. We've got our specs that live in a certain directory. Those files are in there; they're static. You've got the application flow. Now you can view the application flow when you're running your app, of course, through specs, or if it's running on some sort of environment that can receive requests, or even from the terminal. You pop open your terminal, run in the application. Then that moment where you have your application flow. And of course, then it's when you're running the application in the same way that you can see the state. You can get in at those various points. You can interpret objects. You can interpret the database, parameters, anything else that is alive inside the application. And what Hyperlayer does is it combines all of those things in a visualization layer. And the reason that's important is because it removes a lot of what we have to do manually when we're debugging apps. You think we are the glue that holds the code, the application flow, and the state together. That process is extremely manual. We're interpreting the code to understand the application flow, and then we're interpreting the objects to understand the state. And we can do that sometimes through actually running the application and playing around, or sometimes just by looking at it and trying to compile it in our heads. And so the answer to the question, where does the time save come from? Why is this faster? Is that, by significantly reducing the number of steps, by making that process more accurate, by pushing it into a visualization layer. That's where that improvement and that's where that benefit comes from. And, it represents a paradigm shift in how we are engineering software. And, that's big talk, but I feel like it sufficiently transforms the process enough for saying that to be justified. We are drastically cutting out the number of steps. We're drastically cutting out the cognitive overhead that goes into debugging an application. You'll see, I think, the evidence that supports that as I show you the tool. And the biggest thing for me is this thing works out of the box. I think there are a lot of tools that exist that promise lots of benefits, new paradigms, shifts in how we can build and debug software, but you have to start out with this application framework, or you have to start building in this cloud-based tool. And of course, for a lot of us, that's not an option. We have production applications running that are extremely mature that we can't just throw out. And so those teams of people that are working on those applications, that are spending that time debugging them, this application will allow these teams, which at this point I believe is most, to get off the ground and to start getting to the bottom of these issues more quickly and doing what developers prefer doing, which is actually writing and building software. And this is just the beginning. It's born out of a frustration with how software development works right now. And I think with just this first step of debugging applications more quickly, this new view, this innovation of a new way to look at applications, I think becomes the first step on the path of what could be a new platform. And so why Hyperlayer? If that's the what is it, what's the why? Well, depending on which research you look at, developers can spend up to 25 to 50% of their time per year on debugging. Now, of course, from a business product perspective, time spent debugging is time not spent building features and putting value into customers' hands. But of course, debugging is not, for a software engineer, the most fun part of the process. And so this as a problem is huge. If we can improve the efficiency at which software can be built, the impact that this could have is immeasurable. And so let me show you how Hyperlayer is going to change that. But first, let's meet our app. A demo wouldn't be a demo without a good example. And so this application is a vending machine app. This vending machine that we have here works like any typical vending machine. You walk up to it, you put some coins in, you pick the product you want off the shelf, you pop in the item code on the keypad. The system checks that you have enough funds available, and then it vends the machine into the tray and out it comes. And this is the implementation on the right that we have of my vending machine. Thanks to ChatGPT for providing it. So you see in the bottom, we have the vending machine class itself. This is the class that does all of the heavy lifting. We've got the transaction, which is where the guts of the transaction lives. We have the pocket, which represents the customer in this transaction. We have the percentage discount class, which is a part of a strategy pattern. You have the item, which represents the product on the shelf. Gem file, which is extremely tight, just has 2 gems in it. We have the discount superclass, buy one, get one free, another discount strategy class. We have the balance, which of course represents the funds that the customer has inside the machine. And then we have the vending machine spec itself. This is the vending machine, a high level implementation. I don't think there's any point in getting bogged down in the details of the vending machine right now. We will see it later, but as a top level picture, as a top level understanding. So you see here, we instantiate the vending machine itself, the customer pocket. These are the 3 purchases that we want to make with this vending machine. We've got the chocolate, we've got candy, we've got gum. You can see there's a coin here. These represent, by the way, what the customer is putting into the machine, what the customer expects. And then we have the quantity here. So we want to buy one of each of these things. So for each of these purchases, we insert some money into the machine, which is the amount of money you see here. We buy the product by passing through the product name and the pocket, so we can walk away with that thing. And then we have 2 assertions down here. So we assert that the customer receives the right number of products when they walk away. 3 things represented above: chocolate, candy, gum. And then we assert that the machine returns the right amount of change. Here, that's 32 pence. If we run that bottom spec, fails. The spec above it passes, I can tell you that. This spec fails. You can see that we're expecting 32, let's call it pence, back, but we got 50. Now, of course, that's a big problem in vending machine world. It's not the most, currently it's not the most profitable vending machine in the world. And so now begins our hunt, right? We need to dig into this application and we need to understand why this is incorrect. And what I would do in our Hyperlayer world is I would add the Hyperlayer gem to the application gem file. I would bundle install, and then then Hyperlayer is injected into our spec. Any code that runs within a spec is automatically instrumented, and the events are emitted to the Hyperlayer client application for visualization. It doesn't have to be RSpec. For the purposes of the demo, I'm using RSpec to keep things simple, but you can wrap any code in the Hyperlayer block, essentially, to emit the events in the format that Hyperlayer requires to do its crunching and do its visualization. Okay, so let's jump straight into Hyperlayer. Now, this is the first view you'll see. This is a record of every spec process that has been run while your application has been instrumented. You can see here that I've had the gem installed for a while on our vending machine. The number just represents the process number from our spec itself. Literally, it's process that is it's assigned when you spin it up, and then the number of specs that were executed inside that process. So if we scroll down to the bottom, we'll see the process run that is responsible for that failing spec we just looked at. Click through, you'll see what spec file it was that failed. Spec, vending machine spec, and there are 2 example groups inside there. Click through again, you'll see the representation essentially that comes from the spec file itself. So describe buying items, it returns the right amount of change. So if I click through, it returns the right amount of change. You're going to get the hyperlayer view of that specification that's just run. Now, the application has run the spec. It's emitted all of the all of the method calls, all of the method returns, and Hyperlayer has crunched those events, and it has built a representation of the application that is this. So I'll just give you an intro just to see what these things look like. So from top to bottom, you've got the application run order. So we can see that the first method that is called here is initialize on vending machine. Now, this represents the arguments that were sent to that method. In this instance, there are none. Then the next line is the return value of that method. Now, these sub method calls are everything that initialize calls to get to its return value. So vending machine initialize is called. It calls item initialize with these arguments. So chocolate, the price of 90 pence, stock of 2. And then we do the same for candy, gum, pretzels, mints. And then we initialize the balance. And then we initialize a percentage discount class with, you can see here, a 10% argument. Now, the way this works is initialize is called, which calls the item initialize. Once this is initialized, it passes back up, and then it calls this, which passes back up, then it calls this, which passes back up, and so on and so forth. And you can tell that because of the alignment of these items. Now, if I scroll down, you can see, and we'll get back to here, but just so the indentation makes sense. Here, the vending machine buy method calls transaction initialize, which passes back up to buy, which calls execute, which calls can execute, which calls sufficient funds before it passes its value back up, which calls enough stock, which goes back up. And you can see how it cascades, and every time you're just passing that return value back up. And already here we can get a pretty good story. We can get a pretty good view of what's happening in the application, right? So we are calling the vending machine initialize class. You can see all of the methods that are called in order to achieve that. You can see the state. You can see what's being passed in. You can see what's being passed back. This tells a story without actually having to look at the implementation of the code, which we can do. We'll get to that. And so just by scanning, I can see what the app's doing. It's initializing the items, okay. It's initializing the balance object and the discount object. Then we hit the first kind of main usage method, which is insert money. We can see the classes that are involved in that. So it's the vending machine insert money. We can see that then that's past the balance, which we know we saw was instantiated a bit earlier. Then we initialize the pocket. Then we get into this buy process, which, as we know, is the heavy lifting. Really, is the job the application is doing. And we can just trace the whole execution by eye, looking at, okay, there's no discount here. No discount pass through. You can see the price, the state, the items, that kind of thing. And that goes through all the way down. And then we see the process starts again. This is us buying the second product, which is in this case, the candy. Again, we can see the ordering. And this is the same at this point. onto the third item, which is gum, inserting the money for that. And then we go through that third buying process. And we can see here now we've got the introduction of discount. We've got a couple of discount classes in the app. We can see which discount class it's calling. We saw earlier, if we scroll back up, that is initialized with a 10% discount amount. You know, and straight off the bat, you think we've come into this to solve a bug, which is the incorrect amount of changes being given to the user. And it's our job as software engineers to form some sort of hypothesis based on what could be causing that, based on our understanding of the application. And of course, we don't always have prior knowledge of the code to which we're picking up a bug for, but this gives you a hell of a head start. We come to hypothesize. You know, we're thinking about something that is to do with the balance that's passed around. We are thinking about pricing. We are thinking about the pocket object. You know, there is a percentage discount class here. And so we'll just have a little scroll through. Now, we are already off the bat, I can see that the 10% is the discount amount here, that we've initialized the correct number of items, 2, 3, 4, 4 and 2. We're only trying to buy one of each thing, so I don't think it's that. We're initializing the balance here as 0. That's good. Yeah, we can see the percentage discount is initialized here as 10. Now, let's follow this through. So the customer's putting 100 pence inside the application. That is passed here onto the balance itself. The pocket is initialized, just a 0 return value. And we can have a look at that shortly, see if that's meaningful. Now we are into the buy process. So first item that's coming out, customer's buying some chocolate. We've got the customer pocket here. Excuse the representation of the objects, just haven't spent the time to serialize these, but my aim is to have the full object here so you can click on it and you can explore that properly. So we've got buy, which initializes a transaction. Here's the item, which is the chocolate. We've got the balance and we've got the customer pocket. Then we go from initialize to execute. Now in the execute subtree, that was a success. And we look at, okay, well, how does that transaction execute? So it first checks, can it execute? You can see there's no discount passed in here. There wasn't one above. It can execute because it's sufficient funds and it's enough stock. So because both of these are true. Now, if we just want to look at the code here, I can click that and that is going to load up the view of the code. It's going to scroll me into the right place and it's going to show me. And you can see here, can execute, sufficient funds, enough stock, return value true. And that's true because sufficient funds is true and enough stock is true. And okay, so it can execute, complete transaction. We've got the discounted price here, 0. Well, why is that 0? Okay, that's 0 because the last thing we're calling here is clear balance, which makes sense. After we've added the change to the customer pocket, it makes sense that we'll wipe the balance back down to 0. And if I just scroll down, you can see the code representation in the same fashion as the events in the background, which is the indentation represents how the return value is passed around. And so we've got add item to customer pocket here. We've got, which then calls, okay, that makes sense because that's an instance of pocket. So it's calling add item on pocket. Then we've got reduce the item stock, which calls item to reduce its stock. And then we've got calculate change here, balance amount, discounted price, 10. And then we've got customer pocket add. Okay, so 10 is going in there. That makes sense. Got 100 pence into this vending machine. Bar of chocolate costs 90 pence. We want one of them. That's of course going to give us 10 pence back. And then going into the customer's pocket here is 10 change. We clear the balance, 0. That 0 has come from the balance class calling clear balance itself, 0. And that's why we have the 0 here in complete transaction. So that's fine, that adds up. We've seen, right amount of change going into the customer's pocket, 10, good, keep going. So we go again, second purchase this time. On the second loop, we are inserting 50, which we can see goes into the balance correctly. Now we're buying the candy, customer pocket. Again, it's a success. We initialize the transaction, same as we did above. Execute, no discount. Again, this time, success. Sufficient funds, enough stock. Both of those are fine. Complete the transaction. That's 0 for the same reason, because clear balance lands us back on 0. That's great. Add item to pocket, reduce item stock to calculate change. Why is that 0? That's 0 because the price is 50 and we put 50 in. Cool, that makes sense. And you can see, just scanning. I'm scanning, I'm dropping in, I'm checking the implementation where I'm not clear on it, and I can just see it. I'm not having to look through the code and build any kind of mental map of it. I'm not looking for points of interest, thinking, oh, what does that get hit? Maybe that gets hit, and that's that. I'm not having to evaluate any conditionals. I've not even ran the code a second time. I've not run the spec more than once. I'm spending my time with the behavior of the application, with the transformations of the application. And so we keep going through. So we got the candy, that's fine. Reduce the stock, that's fine. Change it, we said that's 0. Add the change to customer pocket, 0. Well, that's 10, which is weird. So let's have a look. Add the change plus amount. Okay, so that's the 10 change that we put in initially. That makes sense. It makes sense that the change that's gone into the customer's pocket already is still in the customer's pocket. So that adds up, and again, that was 0. So we're on to the third product. We insert 40 pence. What we're buying? We're buying the gum, passing through the customer pocket. It's a success. This all looks good. Now this time we've got a discount in play. We've got a percentage discount. We saw, scroll back up, 10% discount, 10% discount. Pass through to the transaction, which is passed through to can execute. We've got sufficient funds. We've got percentage discount apply here. Why is that 0? And that, we have our problem. The price for this is coming out as 0 because that 2i shouldn't be there. We got enough stock, complete transaction. Yeah, look, discounted price has gone through as 0. We're adding the item to the pocket. We've reduced the stock. We've calculated the change, and we've put the 40 that they put in. We've given that back to the customer. We put that in their pocket. And we can see we've got the 10 pence in here from the chocolate bar purchase. There was no change from the second purchase, and we've just put 40 pence back in. And so this is our issue. And at this point, we've been able to debug this without having to manually browse through our code base. We haven't had to manually, cognitively process the code, build up that mental map. We haven't had to compute any logic in our head, any if item is found. We haven't had to do any of that. We haven't actually had to run the code a second time, third time, fourth time. We've not had to look for points of interest inside the code base or add any binding price. It's all here. So now, having identified what looks like the root cause in Hyperlayer, I pop open the percentage discount class and I have removed the .2i that was being called on this line here. And you can see that the problem that was causing percentage discount class is going to be reducing a number. In this case, it was reducing it down to a fractional number. And by calling 2i on it, it's rounding it back up, giving us essentially the wrong thing out the end. So change made, we rerun the spec, boom, it's green. Problem solved. We fixed our bug. And you've seen I haven't had to browse through files and directories. I haven't had to piece them together in my mind, you know, looking at which methods are calling which method, which transformations they're calling on objects even. I haven't had to evaluate conditionals and try and understand, okay, where is the application going? What is it doing? It's just there in front of me. I haven't had to use binding pry to interpret the application flow or the objects. I haven't had to look, okay, well, what's being returned from that? You know, where's that going after that? I haven't had to do that using binding pry. It's just there in front of me. I'm able to follow the application narrative just by scrolling top to bottom, reading it as if it was a flowchart. And I don't know if you noticed, but in order to get to the root cause of our issue, I haven't had to run the application a second time. And that's where the time save comes from. You know, this is it's all of this that I've mentioned here, where the time goes. It's manually trying to build up that picture of how an application is working. It's trying to connect all of the pieces together. It's having to go through that. You know, we're purchasing 3 products. I haven't had to go through that once and remember the state and see what's happened again and go in and find my points of interest and add binding pries to inspect the flow and the objects and go round and round. I haven't had to do any of that. I have added Hyperlayer to the gem file. I have run the spec and I have just scrolled and I have consumed and digested the application narrative as it is presented in front of me, which is the biggest source of truth. It's the only source of truth that we've had like this. You know, we've just simply never had this kind of view, and it allows you to get to the bottom of behavior issues in your application super quickly. And so just some closing notes. You know, this is a simple example. I think I've got 10 classes inside what is, of course, a pretty contrived demo. You know, I am familiar with the app. Like I said, ChatGPT generated that example for me. I'm not super familiar with it, but I have been through the code. I know how it plugs together. And that has meant that the implementation of some of the methods are in my head. Appreciate they're not in your head. And so what that means, I think, is as you progress from that scale of I don't know the implementation to okay, I'm familiar with the implementation, and that can happen. Maybe you've picked up a ticket to fix a bug that you've never worked on the code for. Maybe it's super fresh, it's in your head, and that puts you in kind of the sweet spot. Or maybe you wrote that code a few weeks ago and you've done things since and you've forgotten, you're unfamiliar and you need to refresh. The point is, you will spend more time in that code view, right? You know, you will still save tons of time being able to just run the spec, open up Hyperlayer, view, okay, implementation, click on the method, see the code, and just scroll down the modal. You know, you can see what's happening till you're familiar. And then you can close that. And again, you can just look at the top narrative and scroll down to understand what is happening. And look, this is a proof of concept. You know, I have worked on this. I've iterated this for a long time. You know, I've taken a feeling, you know, a frustration, you know, and I've shaped that over time into this, which I think is the most usable tool it's ever been. And it's really an invitation for feedback and comments. You know, I've wanted to highlight some new concepts. You know, there are new concepts in here, and it's been, I want this to be a chance to highlight maybe a different way of doing things, to shine some light on a new potential path. You know, this is, I said at the beginning, this is just the beginning. I think with feedback and thoughts, and, you know, if I can continue to get this to a point where it needs to be and people can embrace it, you know, I think this has the potential to be an absolute game changer in how we read and write code and build software as a whole. And so please do reach out, you know, email, got LinkedIn, you know, however that is, reach out and let's have a conversation. I will be posting the code. It's a bit rough around the edges at the moment. I need to get that into good shape. It shouldn't take too long, but then I can get that online. The priority here was about drawing a line in the sand and saying this has been in my head for too long. It's been only me that has used this thing. Let's start getting it to the hands of people. Let's start getting their opinions and their expertise to help shape it and to move this philosophy, this idea, this new paradigm forwards. And thank you for watching.